Today, let's talk about Wernicke-Korsakoff syndrome.
So what really is Wernicke-Korsakoff syndrome? Wernicke-Korsakoff syndrome, or WKS, refers to a spectrum of neurological diseases including both Wernicke encephalopathy and Korsakoff syndrome. Wernicke encephalopathy causes acute brain damage in lower parts of the brain, thalamus, and hypothalamus. Korsakoff syndrome, on the other hand, results in permanent damage to areas of the brain involved with memory. The disorder is often caused by a deficiency in thiamine, which is also known as vitamin B1, and can be found in foods such as cereals, pork, fish, and beans. Although WKS is typically linked to alcohol, it is not the only cause. In this video, we will go into more detail about the symptoms, causes, diagnosis, and treatment of the disorder. We will begin by discussing the symptoms of WKS. Since WKS is a spectrum involving Wernicke encephalopathy and Korsakoff syndrome, these patients experience symptoms that are related to both diseases. Classic symptoms of Wernicke encephalopathy include confusion, ophthalmoplegia, and ataxia. On the other hand, Korsakoff syndrome symptoms include amnesia, personality changes, and confabulation.
Next, let's explore the importance of thiamine and some causes of the syndrome. Thiamine is a water-soluble B vitamin. It's not produced by the body and must be obtained orally in the diet. Thiamine is absorbed in the duodenum and is stored in the liver. Thiamine is activated by enzymes to become the active form, known as thiamine pyrophosphate, or TPP. TPP is an important cofactor for glucose metabolism. It's also involved in the synthesis of ATP, neurotransmitters, myelin, nucleic acids, as well as protective against oxidative stress damage and important for nerve membrane function. Due to its high energy requirement, the brain is the most susceptible to damage caused by a thiamine deficiency. Let's talk specifically about alcohol, which is a major cause of Wernicke-Korsakoff syndrome. Alcohol blocks the enzyme that activates thiamine, which decreases glucose metabolism. Alcohol downregulates the gene expression of the thiamine transporter, making it harder for the body to absorb. Liver damage decreases the thiamine storage capacity. Furthermore, alcoholics tend to consume carbohydrate-heavy diets instead of vitamin-rich foods, decreasing their thiamine intake. Alcohol also affects renal epithelial cells, leading to more thiamine loss in the urine. In non-alcohol-related disease, there are 4 possible mechanisms. The first, decreased availability caused by starvation, malnutrition, malabsorption, or excess vomiting. Second, an impaired utilization of thiamine. Third, accelerated usage caused by increased metabolic rate, such as with cancer cells that grow and divide rapidly. And lastly, an increase of loss of thiamine. So, how do we diagnose this disease? The first step in diagnosis is to form a clinical impression. You would check the patient's alcohol and food consumption habits. We're also looking for classical symptoms of confusion, ophthalmoplegia, ataxia, amnesia, and mental status changes. This would be confirmed with a neuropsychiatric test. Next, you could perform labs, such as a complete blood count, liver function test, and measure thiamine levels. Lastly, you would confirm using an MRI to evaluate the degradation of the mammary bodies, thalamus, and midbrain. Here's an example of an MRI where you can clearly see the atrophy of the brain regions.
We can now look at some available treatments for WKS. In terms of treatment, physicians often prescribe patients a high dose of oral thiamine, around 200 mg per day accompanied by vitamin B strong tablets. However, recent research has shown that this approach may actually not be adequate. This is because even in healthy individuals, a maximum of 4.5 mg of thiamine will be absorbed from any oral dose greater than 30 mg. We can only assume that this number would be lower for patients suffering from malabsorption issues, such as alcoholics. Therefore, the current treatment for alcohol-dependent patients is daily intramuscular injections that deliver 250 mg of thiamine, which has shown better absorption results when compared to oral supplementation. Researchers are also developing additional ways to improve thiamine delivery. For example, lipid forms of thiamine are being investigated to produce higher bioavailability. Another option is to add thiamine to beer and bread to fortify foods. However, these options are not yet widely used and have their own disadvantages that need to be considered. Additional research is still needed to improve WKS treatment, and awareness should be raised about this topic to increase prophylactic prevention for vulnerable populations.